um, mail to the relevant email ID.
Okay, fine.
Today's speaker is Aniket Ganesh. It's better to introduce him. He is the head of Sanskrita Samiti at IITM campus. He is a fourth year student of engineering physics. He's pursuing BTech in that. More from Aniket then.
Yes, I mean, first of all, thank you for Ganesh for inviting me here. So yeah, today's talk I've structured in two sections. The first will be covering some generic portions of Chandas. The second, as he said, will be on Indian astronomy with an emphasis on Neelakantha Somayari's contributions. So let us start with a short prayer. या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती शेषजाड्यापहा. Namaste Devabhāṣā. Let us get started with this Chandas. So, what exactly is Chandas? How many of you have heard of this word before? And yes, throughout the talk, just feel free to unmute yourself and ask questions or answer whatever I ask. So, what since have you heard of this word Chandas before, any of you?
Yeah.
Okay. So, yeah, Chandas is a word you may come across in poetry. If we take a step back, Chandas is one of the 6 Vedangas. So, what is a Vedanga? It is a part of the Veda, as in the Veda is imagined as a person, and 6 body parts of the Veda are described in Paniniya Shiksha. They are described in this verse. See, it says, Chandah padau tu vedasya hastau kalposa pathyate jyotishamayana chakshur niruktan shrotramuchyate shiksha dhranam tu vedasya mukham vyakaranam smritam tasmat sangamadhitavyam brahmaloke mahiyate. This Veda is imagined as a person, and the padau, the feet of the Veda, are said to be Chandas. The hastau, the hands, are said to be Kalpa, which is another Vedanga. Jyotisham ayanam. This is, in fact, this will be the second portion of the talk. Jyotisha is astronomy. Of course, in the modern sense, we understand it as astrology, but generally, Jyotisha in the classical sense refers to astronomy primarily. Jyotishamayanam chakshuhu, the eye of the Veda, is said to be astronomy. Niruktam shrotramuchyate. Nirukta is another Vedanga. It deals with etymology of Vedic words. Vedic words are not, not like classical words where if you understand the classical sense, we'll get some meaning. In the Vedic sense, the same words may have some different meanings. That is all dealt with in this Nirukta. Kalpa that we saw before, Hastau, Kalpa. Kalpa is a Shastra that deals with rituals, how Vedic rituals are supposed to be performed. Shiksha, Ghranantu Vedasya. This Ghrana, what is Ghrana? Yeah. Anyone?
ग्रहण करना.
Grahan is different. Ghrana is a body part. Have any of you come across? So this Shiksha, it is a Vedanga that deals with pronunciation. What is the correct pronunciation of Sanskrit words? Ghrana refers to the sense of smell or the nose. So this Shiksha Shastra is said to be the nose of the Veda. And Mukham Vyakaranam Smritam. Mukham, the face or mouth of the Veda, is said to be Vyakaranam, grammar. or morphology. Vyakarana is not exactly grammar, it deals with how words are derived, etc. So yeah, this is how the Veda is pictured, and its different parts. It has 6 parts. Tasmat sangam adhityaiva brahmaloke mahiyate. Therefore, only a person who learns this Veda along with its 6 parts, sa angam, he will adhityaiva brahmaloke pahiyate. He will be respected in brahmaloka. Only if you learn, it is not sufficient to just learn the Veda, you have to learn it along with the 6 parts. So yeah, out of these 6 parts, one of them is Chandas, the feet of the Veda. So Chandas deals with poetry, that is some ordered arrangement of the syllables that you see in some sort of speech, some constrained speech that is constrained by the order of syllables, the length of syllables spoken. That kind of speech is called Chando Baddha Vak. That is, it is constrained by Chandas. And this Veda, it is composed mostly in Chandas. It will be, you will have some sort of rhythmic pattern in all the way, most of the Vedic hymns. In fact, Chandas is used as a synonym for Veda in Panini. You will say, if Panini says Chandas, it means this Chandasi. If he says, it means that sort of usage is applicable only in the Chandas or the Veda. It is not applicable in common usage. So this Chandas is intimately related with the Veda. Is the point that you need to understand from this. It is a Vedanga, and the Veda mantras are all in some Chandases. So, so Chandas is an ordered arrangement of syllables. 7 different categories of Chandases have been described. They are well known. Gayatri, Ushnik, Anushtup, Brihati, Pankti, Trishtup, Jagati. These are the 7 categories of Chandases. Let us go, Gayatri, there are definitions for each of these. We'll go over them in order. So yeah, Chandas Shastra, this a systematic treatment of Chandases. See, so in the Veda, you just have verses in many different poetic fashions. Some mantra will be in, say, Gayatri Chandas. What exactly is the Gayatri Chandas now? It is not that every Gayatri Chandas will be exactly the same. You'll have many variations in that also. So, for doing a systematic treatment of all of these, Pingalacharya had composed some sutras. Have any of you come across the term sutra before in any context?
We have the Patanjali Yoga Sutras as well.
Correct. Patanjali Yoga Sutra is a famous. Have any of you heard of Panini's Vyakarana Sutras?
Yep, the Ashtadhyayi.
Ashtadhyayi. So what is a sutra? There are some characteristics that define a sutra.
It should be short, it should be clear, and most of the information should be
Exactly.
conveyed.
So, Alpaksharam Asandigdham Saravad Vishwatomukham Astobham Anavadyancha Sutram Sutravido Viduhu. Alpakshara. First criterion is that it should be Alpakshara. It should be very concise. The brevity is very important. You should not use a single syllable extra. In fact, in Vyakarana circles, there is a popular saying, Ardhamatra Laghavena Putrotsavam Manyante Vyakarana. If you reduce you want to describe some rule, if you state that rule, so to state that rule, you'll have some sutras. If you reduce that sutra by half a syllable, Vyakaranas will celebrate it as if it is the birth of a child. So that much importance is given to conciseness of the sutras. Alpaksharam asandigdham. It should not be very confusing. Saravat should contain the essence. Vishwatomukham, etc. Many other criteria are given. The important part that we need to pay attention to is that sutra is a very concise form. It is a compressed form of conveying some information. So the Chandas Sutras, as the name suggests, they are composed as very terse, short, concise, crisp sutras. And it deals with Vedic meters in a lot of detail. In fact, the bunch of it is also an Ashtadhyayi, by the way. Chandas Shastra also has 8 chapters. In that, some of the chapters are dedicated entirely to Vedic meters, and then he describes Laukika meters also. And since this is in such a terse, concise form, it is typically to be understood only with some sort of commentary. And we have this Bhatta Halayudha's Mrita Sanjeevani, which was composed around 10th century too. And this is a commentary on Pingala's Chandas Sutra. It explains it in some detail so that we can understand what it is about. In fact, this name Mrita Sanjeevani, it suggests that this Chandas Shastra was not very popular perhaps in his time, so that by writing this commentary he was sort of reviving it. Is one theory that has been suggested. So this is the original work, that is the oldest work that we know dealing with Chandas in particular in great detail, systematic procedure, is the Pingalacharya's Chandas Sutras. Then we have a very popular work, Kedara Bhatta's Vrittaratnakara. This is not expressed in sutras as was the old style. Kedara Bhatta explains it lucidly in nice verses. For example, we have a comparison here. We have this meter called Svagata. This is how Chandas Sutras describe it. Svagatar Naubhakaug. That is the sutra describing, giving the lakshana of Svagata meter. Again, a meter is just a Chandas. It is some arrangement of syllables. We'll get back to all this in detail. Svagatar Naubhakaug. It is the sutra describes the lakshana of Svagata. Vrittaratnakara, he gives the definition of Svagata in the Svagata meter itself. Svagate Tiranabhat Guru Yogmam. This verse is in Svagata meter and it gives the definition of Svagata. All of these. So this Vrittaratnakara has become very popular, perhaps for this reason, and it gives the definitions of all the meters in that meter itself. Now we'll move on to the basics of Chanda Shastra, the technical aspects. Some definitions. Whatever field you study, you will start with some basic definitions defined for that particular field. Laghu and Guru. Have you heard of these words before in any context?
Yes.
Yes.
These are matras.
Matras. Yes. So what is Laghu?
It's a choti matra, choti.
Choti matra. Correct. So the sutra defining Laghu is 1.9. Grill. This is the sutra. Grill. That is L. The L at the end stands for Laghu. And Gr, the time it takes to say Gr, that is defined as Laghu. Why Gr? Why not some Sr or Kr or something? We'll see that later. The time it takes to say Gr. So the Laghu is a time taken, rather it is a short vowel. A short vowel. So what are the short vowels? A, I, U, R, L. These 5 are the short vowels. If any of you are aware of the Maheshwara Sutras, I, Un, Ridik. So these 5 will be the short vowels. The long vowels also we are aware. A, I, U, R, N, A, O, I, O. These are the long vowels. These are not laghus. So this is the definition of laghu. Laghu is a short vowel, one of these 5. Long vowel is defined as this He says that all these long vowels are called gurus. A, I, U, the long R, A, O, I, O. This long R may be a little confusing because it does not occur in Hindi. It exists in Sanskrit. This is a long vowel, and it is all these long vowels are described as gurus. Something else, other things are also described as gurus. We'll see what they are. If you have any vowel followed by a conjunct consonant, a sanyukta akshara, for example, samyukta itself you can take. U, U is a short vowel. Sanyukta, if you say U is a short vowel, but it is followed by this kt, ka and ta, this samyukta akshara. So it takes more time to say yukta than yuta. Just U, this yukta, that is said for longer time, so it is also considered a guru. And interestingly, he says Gante, this G standing for Guru, Ante, whatever letter comes at the end of a pada, we'll see what a pada is. Whatever letter comes at the end of a meter, that is automatically defined to be Guru. Be it Lahu, be it this Samyukta Akshara, whatever it is automatically defined to be Guru, what the end syllable. So this is the definition of Laghu and Guru. And this Guru is said to be Lausaha. It is consisted of 2 laus, 2 lakaras. That is lau is in Vivachana. So this Guru takes twice the amount of time it takes to say Laghu. Okay, so these are the basic definitions. Any questions here? Okay, I'm assuming that means this is all fine. If that is fine, now he goes on to define some ganas. This will form the structure of the rest of the Chandas Shastra. You understand these ganas, Guru, Laghu, then these ganas. Based on this only, he will be defining all the meters. So these ganas he describes in the first chapter, Dhi, Shri, Stri, Varasa, etc. So if we take this Dhi, Shri, Stri, this Makara at the end, that Ma, the Gana's name is actually Ma or Magana. The Ma Gana consists of Guru, Guru, Guru. Yes, I forgot to mention here, this Laghu is generally denoted by this line, straight line. Guru is generally denoted by the curved line. Those are just conventional symbols. So this Magana is defined as 3 Guru syllables. Guru, Guru, Guru is called, if you have Guru, 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 that is called a Magana. Gana just means group. Ganapati, Gana, Jana, Gana, Mana. So this Gana just means a group of things. Here it is a group of syllables. Group of how many syllables? 3 syllables. So this Magana is a group of 3 Gurus. Ya Gana is Va, Ra, Sa. This Laghu, Guru, Guru. That is Yagana. Similarly, Ragana, Sagana, Tagana. These 8 ganas are defined. Why 8 ganas? Can anyone say why there are only 8 ganas? Why not more? How many ganas can you have of 3 syllables?
2 to the power 3.
2 to the power 3. That is all. So all these ganas have been given some names. And this mnemonic at the bottom that you can see. Can you see my cursor? I mean, is my cursor? Okay, sure. This Yamata Rajabhana Salaga. This is attributed to Panani of the Ashtadhyayi fame. This is some sort of mnemonic for memorizing all the ganas. So see, Ya, Ma, Ta. Yagana is Lagu, Guru, Guru. Ma, Ta, Ra. Magana is Guru, Guru, Guru. So all of these he has arranged in an intelligent fashion so that Yamata Raja Bhana Salaga, if you memorize, you can just start anyway. If I want to say Jagana, I can just say Jabhana Laghu Guru Raghu. That is all. So this is a way to memorize these ganas. So what are these? Uh, why has he given these words exactly? Why he Shri Stream Varasai? There is an interesting story in the commentary. It says uh, Guru is telling his Shishya, He Shri Stream. If you have knowledge, He, then you get Shri, you get wealth. And if you have Shri, you get Stri, you can get married. Yarthamulatva garhasthasya. Only if you have money, you can get married. Varasa. This procedure for starting a household is only the best procedure. Then Shishya asks, Ka Guho, what is the cave or what is the location where I get this dhi? The teacher says, Vasudha. You can get this on the earth only. Sa tekva. Where on the earth? Grihe, at your house. This grihe, so like this it goes. This is a conversation. So it is just a mnemonic perhaps to make the Chandas Sutras also easier to remember, since they are not in any metrical fashion.
Excuse me.
Yeah, sure.
Like, is this similar to Kakha Gaga in Hindi?
I didn't understand your question.
Like, the words Kakha Gaga,
Yes.
are you teaching that in Sanskrit?
No. They are pretty much the same in Sanskrit. This is about prosody, poetry. These are
Okay.
See, no, that is entirely different, right? That is the Varnamala, that will come in Shiksha. We are talking about long syllables, short syllables. E, all of those.
Okay.
If I may interject here,
Sure,
I have a question. Can we move to the last slide?
sure.
Okay. So from this, what I can get here is
Hmm.
Laghu is denoted by that Purna Virama like symbol, right?
Correct, yes.
And Guru is denoted by that S like symbol or Avagraha
Correct, Avagraha, yes.
like symbol.
Correct.
So whenever I write something which has each of these matras,
Hmm.
then I'll use these symbols to denote them, right?
Yes, that is. Yes, correct. In Chanda Shastra, that is the convention. Yes,
That is a convention.
yes.
So can we move to the next slide now, since this is
Yeah.
connected to the next slide? So all of these ganas are just different combinations of those laghu matras and those guru matras, right?
Correct. Maganas, Guru, 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 Yaganas, Lago, Guru, Guru, etc.
Okay, now I get it. Thank you.
Sure. Okay. So, yeah.
So
Any other questions?
yeah, similarly there, those S is because Dhi, Shri and Sri, that is, right?
Stri, yes.
Sri, sorry. So
Mhm.
Sri, Dhi, Shri,
Yes.
Sri are all long vowels, so it is S and S. Similarly,
Perfect. Yes.
yeah. Similarly, Varasa is that way because Va is it is just Va plus A.
Correct.
So
Yes.
it is I like symbol. Then Ra is a long vowel, so it is S like. Then
Correct.
there is Sa, so it is again S, and so
Correct.
on and so forth, right?
Perfect. Yes. That is precisely how this has been written. And I was just saying that these words, why he, Shri, Stri, why not some Kha, Gha, Sa, something? These have some meaning it is structured in form of some conversation between a student and teacher. So yeah, that is about the definition of these ganas. So if we say magana, it means guru, 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 etc. So if you actually go back here, see, you can see Swagateti Ranabhat Guru Yugmam Ranabha. These are the three ganas being used here. So Ra Swagati Ra Na Tirana and then Ranabha Bhad Guru, then Yugmam. That is Guru Yugmam. Now you have so these three. So Swagata is actually Ra, the Ragana, Nagana, Bhagana, and then two Gurus. Yugma means a pair. So Ra, Na, Bhat, Guru Yugmam. That is the definition of Swagata. So this is the way in which they give the definitions of different meters. So Dhruta Vilambita Mahana Bhau Bharau. We'll have Na, Bha, Bha, Ra. That will be the definition of Dhruta Vilambita. You can check. This Na, Bha, Bha, Ra. If you put these together, you will get the pattern that is called Dhruta Vilambita, etc. So this is the way in which they give the definitions of different meters in the Chanda Shastra. So that is fine, right? Okay. So okay, now there are two kinds of meters. You can think of two different ways to have some patterns in using these Laghu Guru. One way is you can constrain the number of syllables that should be there in your sentence. If I say that there should be only 3 syllables, like we saw, you will have 2 to the power 3 combinations. If I say you have 4 syllables, you will have 16 combinations, 2 power 4 combinations. Each of the 4 syllables can be either Laghu or Guru. I can constrain the number of syllables in this way. Or I can say that the total length that has to be taken. We have already assigned Laghu to be a length of 1 and Guru to be a length of twice of that of Laghu, so length of 2. Then if I say that the total length should be 3, I can either have 3 Laghus, 1 Guru Laghu or 1 Laghu Guru, right? So these are the only 3 possibilities. If I say 4, what will be the possibilities? If I want the total length to be 4, how many possibilities, how many different patterns can you have like this?
2 to the power 4.
That will be for syllabic meters. For if I have 4 syllables, then I will have 2 to the power 4. If I say that the total length has to be 4.
Okay. So syllables are 3 and you want the length 4.
No, I don't care about how many syllables should be there. There you can have any number of syllables you want. I want the total length to be 4. Just start listing out what are all the possibilities. Okay, so you can have, if you want total length of 4, Laghu has length 1, Guru has length 2. What are all the different possibilities? Just start listing out from
Okay,
the
so
beginning.
I have to make the combination from Laghu and Guru.
Yes, you can use only Laghu Guru. Those are the only 2 things that we have.
Okay.
So you can have 4 Laghus. Laghu, 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 Laghu. Or what is another possibility that will add up to 4?
1 second. Then there can be 2 Gurus.
2 Gurus, correct. That is one more possibility. Any other possibility?
Laghu, Guru, Laghu.
Laghu, Guru, Laghu, correct. Yes, that is the third possibility. Any other possibility?
I don't think any other possibility.
You
Total
can have
6, I guess.
total 6. What are the 6?
Uh, lagu, 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 4 lagus,
4
and
lagus,
2 gurus,
2
and
gurus.
we would have what do you say, 4 combinations of two lagus and 1 guru.
How do you get 4 combinations there?
Permutations, I mean permutations.
How do you get 4 permutations?
Let me go once again.
So I was not getting for some time. Now I think I get it.
Sure.
The weight of a guru is 2
Correct. Yes.
and the weight of a lagu is 1. So how can we add it
Yes.
in a manner that it becomes 4 total?
Perfect. Yes. 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 That is the question.
Okay, so we can just have all lagus as
Correct.
already
All
listed.
lagus.
Then we can have two gurus since each
Correct.
guru is 2, weight
Hmm.
2. Then we can have one guru and two laghus.
Yes. How? In what orders?
Yeah, the orders are also important. So the
Yes.
guru here can be placed either at the beginning or in the
Correct.
middle or at the end. So there
Correct.
are three such possibilities here. I
Correct.
think we have listed all of the possibilities.
Correct. Yes. Perfect. So you will have a total of 5 such possibilities. If the sum should be 4. Uh, Now, what if the sum should be 5? Okay. Let us start with simple basics. If I should have only one length as 1, how many possibilities are there?
One.
Only one
1.
possibility.
Only one possibility. If I have length of 2, length as 2.
Two
Two,
possibilities.
Two.
two
Correct.
possibilities.
Length as 3, 3 possibilities I have shown here.
Yes.
Length of 4, we saw 5 possibilities.
Yes.
Length of 5, do you observe some pattern here?
Length of 5 we
Fibonacci.
can have
Hmm.
two gurus, one laghu. Again,
Correct.
there can be three options here: start, middle, and
Correct.
end.
Correct.
Then we can have five laghus.
Correct.
Yes.
Just one way is to again go listing all the possibilities. Try to think of some sort of recursion algorithm. Since most of you, I think, are
I think
CS
Fibonacci
oriented.
sequence, I feel I'm getting it.
Uh, why do you think so? I mean,
The
Yes.
number, the number of what is it, possibilities is last number plus the last number. Addition
uh,
of both of them.
so you have observed this pattern. Correct. This pattern seems to follow the Fibonacci sequence, right?
Right.
Uh, Now, can you use some sort of recursive relation to prove this? Just think, it is an interesting, cute little proof. You can use.
Aditya, you can mute yourself. Thank
Yes, please. So, uh, suppose you know the length of, I mean, the number of patterns with n minus 2 syllables, and you know the number of patterns with n minus 1 syllables. How many patterns can you have with n syllables? I have given you f n minus 2 and I have given you f n minus 1. How many? What is f n? Can you quickly
Fn
think of
minus
some?
2 plus Fn minus 1.
Yes. Why is it so?
Because the sum of previous two terms.
Why is it so? Yeah, I want a simple proof for. I mean, this is correct. This is the pattern that you're observing. But why do you think it holds? Can you come up with something based on the definitions we have done? We have seen. So, if you have f n minus 1 possibilities with n minus 1 syllables, uh, and okay, so you know fn minus 2 and fn minus 1. You want to find out fn. So what will fn be? You can either take to consider some the total length should be n. So suppose you have filled n minus 2 of those with some pattern. In how many ways can you fill the final positions.
Can you repeat the question?
Like consider the n. I mean, you want to fill n positions. In
Okay.
that, suppose you fill n minus 2 spaces already you have filled. Then, okay, or consider it this way. You have consider some random pattern with n syllables. This will be easier to understand. Consider a random pattern with n syllables. It can either end in Laghu or Guru. These are the only two possibilities. Right? It cannot end in anything else. Any pattern with n syllables has to end in either Laghu or Guru.
Right.
Now, how many patterns will end with Guru?
Half of the patterns,
Why half?
because
That we do not know. So that we cannot say directly that both will occur with equal probability. So if it has to end with Guru, then it means you are basically counting the number of ways in which you can fill the remaining n minus 2 spaces. Is that right?
yes,
So what will that
Yes.
be? What will that be? It will be f n minus 2. We already know. I mean, I have given you that there are n minus 2 or n minus 2 syllables. There are these many fn minus 2 number of patterns. Right. So if the last letter is Guru for a n syllable n more meter, then the number of such things with last letter being Guru will be fn minus 2. The number of ways to fill these n minus 2. Now, if the last letter is Lahu, how many such patterns are there?
N
Then
minus
I
1.
guess f of n minus 1.
F of n minus 1. Now, if you add these both, you will get f of n. Right?
Right.
So that is the simple proof. So yeah, that is the proof that the number of syllables, number of patterns for a n more a meter actually follows the Fibonacci sequence. And this is actually, in fact, discussed by Pingala. Mishra Ucha or something is the sutra that he gives in the 8th pada. For getting the number of patterns possible for some n more a meter, you should add the previous two added together will give this. Is what Pingala says. This is also described in the Chandas Shastra. Uh, yeah, so an example of the Moraic meter is the Arya. For the syllabic meter also, we have some interesting math going on that will excite CS students, that should excite CS students. For example, suppose consider some pattern with 6 syllables. I am listing them like this. For example, if you have 3 syllables, I am listing them like this. This is the first pattern, second pattern, third pattern, so on. Or if you want, label this as the 0th pattern, first pattern, second pattern, so on. What will be the do you observe some sort of pattern here that you have seen?
These are octal numbers.
These are octal numbers, or rather, they are represented in binary, right?
Yes, 0, 1.
0, 1. So this Laghu, if you take as 0 and Guru, if you take as 1, then these are nothing but binary representations of the numbers, right? So if I have a pattern with 6 syllables, we are talking about syllabic meters here, not Moraic meters. 6 syllables. What will be the, say, fourth pattern in that 6 syllabled meter? What will be the set of Laghu Guru it will have? How will you go about calculating?
Yeah, it will be 0, 1, 1, 111. So Laghu.
0, 111 will be 7, right, in binary.
Yeah. It should be 0, 0, 1, 1.
0,
Is the
0,
fourth
1, 1 is again.
is 3.
It is 3.
0110.
0,
0,
1, 0,
1,
0
1.
is 4.
Correct.
Yeah.
0, 1, 1, 0 would be 6. Yes.
5. Yeah, 6. Yeah.
Yes. But I want 6 syllables. This will be the sixth pattern. This will have like if you say 0, 1, 1, 0, It could be Lahu, Guru, Guru, Lahu. There are still only 4 syllables here. Right. I want a pattern with 6 syllables. So I mean, you just add 2 zeros. You make you will have, it will be 6-digit binary. You will say 0 0 0 0 1 1. 0. Did I add the correct number of zeros? I don't know. 0 0 0 1 1 0. Right. This will be sixth pattern in 6 syllables. I mean, maybe that is too confusing. We take the second pattern. That will be 2 in 6-digit binary. 0 0 0 0 1 0. Right. So Laghu 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 Guru Laghu is the second pattern in a vritta with 6 syllables. Is it clear or is it too fancy?
Okay, so like you are counting from the right side, 0 1 1 0 0 0. Because
I mean, it
2
doesn't
to the
matter.
power,
You will
2
have
to
some
the power
structure.
0 is from 2 to the power 0 is the rightmost bit.
Yes. 2 to the power 0 is the rightmost bit. That is the general convention, right? Yes.
Okay.
I mean, at least in electrical engineering, we keep the LSB to the right only. Okay. Anyway, so you get the sort of binary sort of sequence in syllabic meters. And when counting the number of Mosaic meters possible, you get this Fibonacci sequence. And here, again, in syllabic meters also, Pingalacharya has played a lot of games with, given the nth pattern, given some pattern, find its position. So basically, you have to do binary to decimal. What is the nth pattern? Then you have to do decimal to binary. All these, the procedure for all of this is described in detail in Chandas Shastra. And because of Nashta, Uddishta, all these words are used, and these procedures are all explained there. Now, we are slowly getting to the main portion of the talk. This Anushtup Chanda, have many of you heard of it before? You should have.
Yeah.
Yeah. So again, if you see this Gayatri Chandaha, it is defined as a meter which has 8 syllables in each line. It is a syllabic meter. It has 8 syllables in each line, and it has 3 lines. Tripath Gayatri. So that is the general normal Gayatri. There are many variations. We will not get into any of those. Gayatri generally refers to 24 syllabled meter, that is 3 lines of 8 syllables each. That is the definition of a Gayatri. And the Gayatri Pada, Gayatra Pada is 8 syllables. A Pada is some sort of a set, some set you can say, or a line. Generally, most of the meters will have 4 Padas, will have 4 quarters. So yeah, this Gayatri happens to have only 3, but yes. That is you can say it's an exception.
I have a small doubt.
Sure, yes.
In the Savitri or Gayatri mantra from the Rigveda, in the first pada, why is it that it has 7 syllables only, not 8?
So that the Gayatri mantra is actually in a variation called Nichirit Gayatri Chandaha. So it is not in Gayatri Chandaha. So
Okay.
when you delve into Vedic meters, there is something called Devi Gayatri, Asuri Gayatri, Nichirit Gayatri, Ati Gayatri. So many variations are there. So this Nichirit is one of those variations. I am not very clear on what these variations exactly mean, but yes, they'll have a slightly different number of syllables here and there.
Okay, what was that you mentioned for that particular case?
This is Nichirit Gayatri. Nichirit.
Nichirit. Can you type it if possible?
Sure. Just a minute. I can type it in the chat, right?
Yeah.
Nichirit is the sure. So yeah, all these variations will jump in there. I am not very clear on how they are defined, etc. But yeah. So this Gayatri, you should remember that a Gayatra Pada has 8 syllables, and a Gayatri meter has 3 lines of 8 syllables each. That is the takeaway from here. This Anushtup Chandaha, the name derives from this Upasarga Anu, this prefix Anu, plus the root word Stunbha, Stunbha Rodhani. It is the definition in Dhatu Patha. Stunbha is a root that means to obstruct, some hindrance. So, what is this hindering? गायत्रीमेव त्रिपदां सतीं चतुर्थेन पादेन अनुष्ठोभति इति अनुष्टुप्. This tripadam gayatrim, this gayatri with three padas, it hinders it or obstructs it with a fourth pada, a fourth pada. So Anushtup Gayatri, this is a sutra in Chandas Shastra for defining Anushtup, for defining the Vedic Anushtup. We'll get back to yes. So Anushtup is generally any meter which has 8 syllables arranged in 4 lines, like a total of 32 syllables, 8 syllables in each line. That will be the Anushtup. For example, you have the famous verse from Purusha Sukta. Purusha Sukta is an Anushtup. Many famous suktas you may be aware of would be an Anushtup. Even non-mantras like Vishnu Sahasranamas, suktas will also, many famous ones are an Anushtup. So yes, Anushtup is a very, that is why this was chosen as the highlight of this particular talk. Yeah, so see, Sahasra Shirsha Purusha, you will have 8 syllables. In the entire sukta will go like this. So this is the Vedic Anushtup, where it just needs to have 8 syllables. Some other Vedic constraints are given, but takeaway is it has 8 syllables arranged in 4 lines. The shloka is actually the name of a meter, although in common parlance, any verse we just call it a shloka. It is, if you want to be pedantic, if you want to be a grammar Nazi, if you want to be a Chandas Nazi, you can say, no. See, for example, if someone says, Yakundendu Tushara, that the verse we started this with, that is not a shloka. It is in Shazola Vikreditam. It is not a shloka. So shloka is actually a specific type of Anushtup. Technically, although in common parlance, yes, it is used to refer to any verse in general, but it is actually a specific type of Anushtup verse, and it is very popular. It has become very popular that the name has become applicable to any verse in general, right? So yeah, the shloka, so it is derived from this root shlok. Shlokyate iti shlokaha. Shruyate iti shlokaha, it is another etymology. Shlokyate is something that is praised. So you praise someone with this, so it is shloka. Shruyate iti shlokaha, this is heard, so it is called shloka. See, so these are different etymologies given for this word. It is a type of Anushtup, which means, yes, it will have 32 syllables arranged in 4 padas with 8 syllables each. And it has some additional restrictions also. For example, it has this. This is the definition of a shloka given as a shloka. Shloke shashtham gurudnyeyan sarvatra laghu panchamam dvichatushpadayor hrasvan saptaman dirghamanyayoh. Shloke shashtham gurudnyeyam, the 6th syllable in a shloka's pada is to be guru. A 6th syllable if you count. So this is the lakshana of a shloka. The question mark can be anything. If there's a constraint, I have indicated with a full stop or avagraha. So the 6th syllable, 1, 2, 3, 4, 5, 6. 6th syllable is guru in all the 4 pathas. Guru Jnayam Sarvatra. All the 4 pathas, the 6th syllable is guru. Laghu Panchamam. The 5th syllable is laghu in all the 4 padas. Sarvatra laghu panchamam. Dvichatushpadayoho hrasvam saptamam. in the Dvi, the second, and the Chatush, the fourth pada. Hrasvam Saptama, the Saptama, seventh letter is to be Hrasva. Hrasva is a synonym for Laghu. Hrasva means short, Laghu also means short. So this Dvichatushpadayor Hrasvam Saptamam. The Saptamam Dirghamanyayoho. Saptama is to be long in the other two padas. The second and fourth it is short, the first and third it is long. The remaining can be whatever you want. I mean, of course, this last syllable of a pada, like I mentioned before, it has been defined to be Guru. So even if you have some short letter there, since you extend it, it is defined as Guru. The last letter of a pada you will just extend anyway. And Gita, for example, Mamaka Pandavaschaiva, you will extend that, although it is just Laghu. So they have just defined that whatever occurs at the end of a pada is to be Guru. So, I mean, you can put whatever you want there. This is the constraint, this is the structure of a shloka. The first four can be anything. 5 always has to be short, 6 always has to be long, 7 will alternate between long and short. That is the definition of a shloka. Right, so with that we come to the end of the Chandas section. Any questions you guys have?
Yeah, I was taught to use underscore and U for Laghu and Guru. Like, is it valid or?
Sure, I mean, these are just conventions. In the Indian convention, we use this full stop and avagraha. In the Western convention, they use underscore and U. Both are valid only. I mean, these are just conventions.
Okay.
Yeah, I mean,
and
some people even write L and G. Yes, yes, please.
And you mentioned this Shardula Vikridita, Shalini, Malini. What are all those comes under? Like, aren't they Chandas?
Yes. They are also Chandases. See, Chandas means you actually have these 7 only. Gayatri, Ushnik, Anushtu, Brihadi, Pankti, Trishtu, Jagati. The first, these are the Chandases. In these, you have many Vrittas. For example, Shloka is an Anushtup Vritta. It's a Vritta under the Chandas Anushtup. Under Trishtup, you have many Shalini, Rathodhata. All of that will be Trishtup Vrittas. Like that, you'll have a lot.
Okay, so they are the branches of these main 7 Chandas.
Rather than branches, we could say they are subcategorizations.
Okay.
So these are some super categorizations. Under that, we have some subcategorizations. And in fact, some of these, all of these, Gayatri, Ushnik, all these 7, they are Matra Vrittas, they are syllabic meters. This Arya, if you see, there are some meters which are not syllabic meters. They are Moraic meters. That is the total length taken is what you should look at. For example, Arya should be 4 into 7 plus 2. There is a reason I've written like this, but basically it should be 30 syllables in half an Arya. Sorry, not 30 syllables, 30 moras, 30 matras should be there. So those do not really come under this categorization as far as I know. But yes, Chandases refers to these 7. These different things, Shardula Vikreditam, Shloka, Rathodhita, Upendra Vajra, Shalini, all of these will be different vrittas. That is what they are also meters only. They are all meters, poetic meters. They are all some constraint in the order and pattern of syllables.
Okay, thank you.
Sure. Any other questions?
I just wanted to add to the shloka part that you were telling, like
Sure.
the etymological part. Like
Yes.
there is a reference in Ramayanam, in the Balakanda, so where I'll make it short. Like Maharishi Valmiki was, he was near the river, and he saw 2 craunchas, the heron, Heron. They were indulged in the act of love, and suddenly a hunter kills the male crauncha. So he was grief-stricken, Maharshi Valmiki. So then he cursed that hunter, but later he pondered why he cursed the hunter as like that. So then he told the following words that शोकार्तस्य प्रवृत्तो मे श्लोको भवतु नान्यथा. So because of his
Mm.
shoka, his grief, he will compose it as shloka and nothing else it will be called. So like that's
Ah,
how the shlokas were born by Maharishi Valmiki.
correct, correct, correct. Yes, that is another etymology for shloka. Yes, that is another very interesting etymology. In fact, the curse he gives itself will be in the form of a shloka.
Yes, yes.
And that shloka, I mean, it can be if you shift the words, if you break the words at different places, it can be like a premonition to the Ramayana, something like that. It is there. That is also another very interesting etymology to this shloka. Yes.
Sorry to interject. Should we release the quiz form now?
Ah, sure. I mean, if there are no more questions, we can. I mean, if there are any questions, we can answer all of those and then release the quiz form. We have sufficient. I mean, unless you guys have any constraints. So yeah, are there any more questions? Okay, I mean, there don't seem to be any more questions. I think you can release the form, Ganesh.
Okay. Then we'll also have another section which will be lighter on the mind than this. I hope.
Yes. Oh, yes, it will be. Yes.
So, Sachet, I think you can paste the form in the chat section.
Yes, yes. I'll release just a second.
I think there is also a shloka for Yagana Tagana. I don't remember it properly, but like Adi Madhyavasaneshu Yarata Yanti Lagavam.
Ah, correct, correct, correct. That is also there. Yes, there is a shloka to memorize that also. But I have always found this Yamata Radhabhana Salaga easier to remember. So yeah, yes, there is a
Okay.
shloka for that also. Yeah, the
Uh,
form has been posted in the chat.
a question not directly related to what was taught.
Sure, sure.
I have a question here. Between Chanda and Parichayaha, there seems to be a
Ah,
symbol. What symbol is that?
ah, yes, that is the Upasmaniya. Uh,
Okay,
if you have a visarga before a pakara or thakara,
that
during
becomes
Sandhi it becomes
F-like sound.
Upasmani. Ah, the F-like sound, yes. You don't say Chandaha Parichaya, Chandah Parichaya.
I think in the Gayatri it is there, right? Upatmaniya. Diyo Yonaf Prachodayat.
Correct, correct, correct. Yes, that is the Upasmani sound, yes. So the quiz has 6 questions. Will 10 minutes be sufficient? Or I don't know. Please look at the questions and let me know. Let us not exceed more than 15 minutes, I guess.
Very maths one and stats one like, for those who know.
Yeah, I agree.
I mean, I didn't want it to be another social studies exam where you had to remember something that was told in the talk and then directly reproduce, etc.
Also, to the people who have joined later, um, what you can do is we will upload the recordings and then you can see those recording and then attempt the quiz. So is everyone done or is someone left? Am I audible?
Yes, yes, you are. Everyone has submitted already?
If anyone is left, please let us know.
Ignish, is that, does it mean everyone has submitted already?
I think everyone has, since no one is saying
Okay,
whether they have or not.
I'm still doing it, but we can continue. I'll submit it later.
okay. Uh,
Okay, that works as well. Yeah, the quiz link will also be available in the YouTube video description so that you can attempt it later too. I think we can move on to the next segment.
okay, so yeah, that was about Chandas. It was, we went into a fair amount of technical detail. Neelakantha Somayaji. So this section will just be me fangirling about Neelakantha Somayaji, one of my favorite astronomers. So you can just listen to me rant and chill. But yeah. Uh, so the context. Neelakantha was part of this Kerala school of mathematics and astronomy. Have any of you heard of this before?
Yep.
Yes. So in what context have you heard of them?
And the invention of calculus, like before
Uh,
Newton,
Yes, calculus.
Correct,
Leibniz.
correct. So, yes, so they are known particularly for innovating some ideas of calculus. I mean, perhaps if you want them, at least you can call them pre-calculus. If you are a little skeptical to use the actual term, since they did not, we got the symbols of integration and differentiation not even from Newton. They were innovations by Leibniz. Yeah, so they conceived of a lot of ideas which would eventually lead to the development of calculus. For example, the infinite series, uh, something similar to the Taylor series and all which we know today. Such series were conceived by Madhavacharya of Sangamagrama. So this Madhava here, his primary contribution to the history of science was this infinite series, which is a remarkable achievement in itself. And this Parameshwara, have any of you heard of his name? I don't think so. Madhava is quite famous, even Nilakantha is somewhat famous. Parameshwara is also, he has also contributed a lot. Particularly, he has made astronomical observations over his lifespan, at least some 50 to 60 years in his lifespan, and made an accurate record of eclipses that he observed. Pratyaksha, he observed some eclipses and made some records. And these eclipse records are actually valuable historical data. I mean, if you want to trace even today to make some computations, these historical records of eclipses particularly come in very handy. So yes, Parameshwara is important for that. So you already see Madhava, some groundbreaking achievement he has done. Parameshwara's contribution is in sometimes used even today. So this is the sort of uh, background in which Neelakantha emerges. Yeah, this is just to hype him up. And Jeshtha this Jeshtha you see. So yeah, Madhava's student was Parameshwara. Parameshwara's student was Damodara. Student and son also. Damodara's student was Neelakantha. His student Jeshtha so on. This lineage, this academic lineage continued till sometime in the 1700s, I think. So the Jeshtha uh, actually wrote something called the Yukti-Bhāṣā, where he gives a lot of proofs for many of the theorems stated by his teachers. He writes this Yukti-Bhāṣā in Malayalam. It is surprising. I mean, one of the few academic works that is not in Sanskrit. Yeah, so that is also a very important document today, which shows that, I mean, even though they may not have explicitly mentioned the proofs in whatever, for whatever results they had mentioned, they did know the proofs. Jeshtadeva gives. This Narayana Bhattacharya, this is also another popular figure. Have any of you heard? I mean, it will not be in this context. It should have been in some other context.
He's the author of Narayaniyam.
He's author of Narayaniyam. He was an expert in grammar. He has written this Narayaniyam poem in praise of Narayana, and he was also an expert grammarian, and he was also an astronomer or mathematician. So this is the sort of this background in which we are going to look at Neelakantha. So why am I so obsessed with Neelakantha? He has done, has given a lot of important works. These are some of his important works. I mean, these are not necessarily the most important also. I just picked a few in random. Tantra Sangraha is again, Neelakantha was primarily a mathematician astronomer. In those days, there were no real distinctions between mathematics and astronomy. After all, they wanted to predict some astronomical phenomena, when the next eclipse will happen, when this next full moon, etc. Tithi computations, all of those, you need the positions of the sun and moon. So you have to come up with some cosmological models. You have to come up with a model for the motion of the sun, model the motion of the moon. And for those will obviously involve some sine, cos, and all advanced spherical trigonometry. And to be good at astronomy, you need to be good at mathematics. So yes, that is the context in which math actually emerged in India. So Tantra Sangraha is Neelakantha's own. It is a Tantra. Again, let us not get into much detail here. Tantra Sangraha is a text on astronomy. Aryabhatiya Bhashya. Neelakantha has written a commentary on Aryabhatiya. Aryabhatiya, I hope everyone has heard of. Aryabhata's most famous book. And actually, the only one of, he had actually written at least 2 books, Aryabhatiya and Aryabhata Siddhanta, where, sorry, just a minute. Yes, he had written Aryabhatiya and Aryabhata Siddhanta, of which only Aryabhatiya is available today. And Nilakantha has written a commentary on Aryabhatiya. He just says, Mayadya pravayasa jnata yuktihi pratipadayutum bhaskaradibil anyatha vyakhyātānām karmāņapi pratipadayatum yatha kathanchideva vyakhyanam arabdham. So, because of my experience today, pravayasa, you can say it is either age or experience, I have come to know of some proofs or rationales for the things mentioned in Aryabhatiya. And Bhaskaracharya, etc. Bhaskarādibhir anyatha vyakhyātānām. They have explained it in a different way. So I have come up with some interesting rationales to explain those. Yatha kathanchideva, somewhat serendipitously. Casually, he just states, I started writing this commentary of Aryabhatiya. And he was quite respected even in his own times, as we see in this Sundara Raja Prashnottara. Sundara Raja was a mathematician or astronomer from Tamil Nadu, the neighboring state. There, Sundara Raja, this Tamil astronomer, asks, he has asked Nilakantha some doubts in astronomy. And then the Sundara Raja only, and Nilakantha has written a book answering his questions. Sundara Raja Prashnottara. And in that, Sundara Raja writes in one of his works, Atra tu gati yogam shakenaiva haranam yuktam, some mathematical statement. He is telling, this has been told by Srimat Kerala Sadgrama Nivasi Neelakantharyena Triskandha Vidya Paradrishvana Shad Darshani Parangatena Ashvalayana Sutrena Garga Gotrena Navakalaru Chatena Gola Chudamanina Asmat Anugraharthe Sundara Raja Prashnottara Granthe Pratipaditam. So, he seems to be Srimat Kerala Sadgrama Nivasi. He lives in a good respected village in Kerala, Nilakantha Arya. Nilakantha Sir, he says, Triskandha Vidya Paradrishvana, with 3 shoulders or something, he has exceeded 3 shoulders of education or something to that effect. Shad Darshani Parangatena, he has learnt all the 6 darshanas or philosophies. Like this, he gives some superlative adjectives here. Yeah. And then this Graha Pariksha Krama. This is a text for emphasizing how observation is to be done. Why I am mentioning this is Nilakantha emphasizes the need for observation. We will see that in a little more detail next. And Jyotirmimamsa, which is another text, one of my favorite texts again. It deals not with this Tantra Sangraha is also a text on astronomy. It dealt with the models that he uses, the mathematical models, the sign, equation of the sun, equation of center, all of that. Jyotirmimamsa gives a qualitative outlook on the understanding. Why is this the equation of the sun? Because this is how it moves, something like that. It is not as much mathematically technical as the Tantra Sangraha. Most astronomical texts. Most astronomical texts in the history of Indian astronomy will be like Tantra Sangraha. They'll start off with the text by listing some numbers. These will be the number of revolutions of the sun, moon, etc. in one Mahayuga. How they'll start the text. Jyotirmimamsa is sort of qualitative treatment based on Nilakantha's understanding of how the planets, sun, moon, all of them move. So yes, Nilakantha, as he had promised in his Devabhāṣā, Yatha Kathanchideva Arabdham, some interesting proofs I've come up with. So this is one of these interesting proofs that he gives. This I'm sure all of you would have seen somewhere or the other, right? For the summation of an arithmetic progression, you start off with, if you want a plus d, this is an arithmetic progression. You want the sum of all the terms of an arithmetic progression. You can just start off, say this is a rectangle with side 1 This side is A. This side is A plus D. This side is A plus D plus D. A plus 2D. So on. This is the last term. If I want to find out this sum, what do I do? This is the area that I want. This is the Nilakantha calls it some Shredhi Kshetra. It looks like some staircase. So he says this staircase area is the summation that I want. What will I do? I will just put the staircase ulta. I will put it here. Then I will get a nice and clean rectangle. The area of this rectangle I will know because I am arranging n terms. And this length is just the first term plus last term. So this area is n into first term plus last term. But half of that is the area that I want. So this proof, I will be surprised if you have not come across this proof before. It has become very standard to teach when introducing arithmetic progressions. So this is quite generic. Have any of you come across this sort of series before? The first one again here, it's just an arithmetic progression. 1 plus 2 plus 3 till n. This everyone knows. This Gauss story, famous story is there. N in 10 plus 1 by 2 he gave. All of that. Have any of you come across now? You take this n into n plus 1 by 2. This is some Sn. The sum of terms up till n is n into n plus 1 by 2. You call it Sn. Now do this summation. S1 plus S2 plus S3. 1 into 1 plus 1 by 2. This one summation till one term plus summation till two terms plus summation till three terms plus summation till n terms. I call it some second order summation. It's not square. This is just some second order summation. This sum, have any of you come across? Unlikely. Any of you can just, how would you go about finding this sum today? I mean, if I ask you to find this sum, what would you do? Up to n terms. I mean, generally, how would you proceed? No need to give a final answer. Just how would you start proceeding?
First of all, we need to find the general term of the sequence.
Correct. That we already know. N into n plus 1 by 2 is Sn.
Yes.
I
And
want to demonstrate.
yes, then you can just apply the telescoping method.
Some telescopic method. Or here it will just be n square by 2 plus n by 2, right? That is the term. So basically you just want summation of n square by 2 plus summation of n by 2. Those two you know. You know the sum of squares, you know the sum. So you can do some algebra and get it. So getting this answer, you will finally end up with this value. This is the formula that you will end up with. So getting this answer is not that hard. You can do it algebraically. Now Nilakantha goes ahead and gives a visual proof for this. Yeah. So this is how he starts to visualize why this formula holds. He gives a visual proof for this. He says first you should consider a cuboid. Okay, a cuboid with sides n plus 1, n by 2 and 1. You should consider a cuboid with sides n plus 1, n by 2 and 1. He says, right, you consider this cuboid. Now, why this cuboid we'll see. Now, what will this be? What will be the area volume of this cuboid? This one small cuboid, n plus 1, n plus 2, 1. What will be the volume of this cuboid?
L into V into H.
So what is that? If the sides are n plus 1, n by 2 and 1.
So it would be n square by 4 times n plus 1.
Hey, square by 4. N plus 1 is one side. N by 2 is the other side. Height is 1.
So it would be n times n plus 1.
n into n plus 1 by 2.
N into n plus 1 by 2. That is Sn. So Sn is the volume of one cuboid. Okay, yeah. So Sn is the volume of one cuboid. Consider this one cuboid. It will
These
be
are two
dimensions.
cuboids.
Yes. Here two cuboids are there. One cuboid, n plus 1, n by 2, height 1. That's one cuboid. Its volume is Sn. So he says this is consider one more cuboid like this. stick them together, I mean, you will get this sort of thing. Okay, this is one base. 1 n plus 1 n plus n by 2. The small cuboid. This has a value of Sn. Now, if I stick two of them, what will be the total volume? It will be 2Sn, right?
Yes.
It will be 2Sn, obviously. Now, with this, he's constructing a shape like this. Okay. See, so this n plus 1, 1 n by 2. Again, one more of this cuboid. Now this big cuboid, what it has length n plus 1. It is basically this only n plus 1 1 n plus 1 1. So its volume is again 2Sn, right? Is this diagram somewhat clear?
Yes.
So again, this similarly, this cuboid also will have n plus 1 n and 1, its lengths, its dimensions. So what will be the total volume of the cuboids comprising this figure? You can just quickly, no need to get the full, I mean, what will, here you have one Sn, here you have one Sn, here you have two Sns, here you have two Sns, right? You can just verify that. Or is there anything that is not clear here? So what will be the volume of this particular shape that he is constructing?
Three times of n plus 1.
Three times or
4
three
SN.
times? 4 SN. No, in terms of SN, what will it be? That will be easier for us to work with. How many SNs are there?
3 times n into n plus 1 by 2.
3 times, is it?
Yeah, 3 boxes are there I think, because of that.
Correct. 3 boxes are there, but see, this box, this particular thing is what 1 essence. If you put two of
n into n plus 1 by
them,
2. Yeah.
you get 2 of them in each of the 3 sides that you see here. You have 2 small boxes.
So
Yes.
6Sn.
6 SN. 6 SN is the total volume here. You can verify. I'm not just. I mean, if you stack properly like this, you'll have n plus 1 here. 1 is the height, n plus 2. Like that, I make a bigger box. If I stick two of them together, what will I have? I'll have n plus 1, height being 1. So I'll have n plus 1, height being 1. Same, I'll make a copy of this. n plus 1, n plus 1, n plus 1 match here. This length, so it will stick correctly. n plus 1, n 1. Again, here, if I have n and 1, this length is n plus 1. So I will align this next cuboid like this. N plus 1, n 1. So perfectly it will go and fit. Okay. So the volume of this particular shape, he calls the shape a kuttima, some sort of paved surface. This volume of this kuttima is 6 SN. Now, what are these inner diameters or inner lengths? What will they be? What is this length, for instance? This length. Is my cursor visible?
Yes.
Yes.
So what is this length?
I guess it is n.
N minus 1.
It will be n minus 1 because this length we know as n.
Okay.
And this height is 1. This is n minus 1. Correct. So that is n minus 1. Height is n minus 1. Now what is this?
Okay, so like,
And
why is he doing this? He knows the sum of 1 from 1 to n, that is n
Correct.
times n plus 1 by 2. So is he
Correct.
considering n by 2 times n plus 1 as length times breadth? So he
Yes.
considers,
See, basically he wants a cuboid with volume Sn. He's breaking it in this way. He's breaking it in this way because it gives rise to some interesting shape. We will see that later. When we complete the proof, it will be very
so
beautiful.
then you need n cuboids.
You need n cuboids. Why do you need n cuboids? The volume
Because
of
the
Hmm.
because the one cuboid corresponds to the sum of 1 to n terms, that is n by 2 times n plus 1. Okay. So
Ah,
one rectangle corresponds to that.
Ah,
And okay. Now I'm getting.
huh. So
N into
what
n
is
plus 1 is equal to 2Sn. That's the idea, I think. N into
correct?
n plus
Correct.
1
Correct. Exactly. N into n plus one is 2Sn. Correct.
because of the n by 2
Ah,
is there.
correct. Yes. So this, what is this inner diameter? This inner, this inner
That will be
dimension
n.
is
It is n.
n. Correct. It is n. This we already saw. It was n minus one. This is n, and this one.
n
What will
plus
this
1.
one be? N plus one. Correct.
N plus 1.
So you have n minus 1, n and n plus 1. What were the outer diameters? This is n, this is n, this is n plus 1, n plus 2. So you have n plus 2, n plus 1, n. For a Kuttima, outer dimensions of a Kuttima, the nth Kuttima means it will have what will be the volume of this nth Kuttima? It is 6Sn, right? This is the nth Kuttima. This shape is we are calling it a Kuttima. This nth Kuttima has a volume of 6Sn, and its outer diameters are n plus 2, n plus 1, and n. Inner dimensions are n plus 1, n minus, n plus 1, n and n minus 1. So what will that fit? It will, what will be the dimensions of the n minus 1th Kuttima now? You just have to replace this n with n minus 1. What will you get? N plus 1. If you
So n
replace
plus one, n and n minus one.
n plus 1, n minus 1. You see these numbers popping up here now. N plus 1, n minus 1. So if you make the n minus 1 to Kuttima, it will fit into this. Exactly, it will fit into this. Now the n minus 2 to Kuttima will fit into that. It is just induction, right? N minus 2 to Kuttima will fit into that. So what will be the volume of the n minus 1 to Kuttima? It will just be 6Sn minus 1. The nth Kuttima 6Sn. I mean, it is the same thing, just scaled up, scaled
Yes.
down. So it will just be what will it be? It will be 6 times is n minus 1, and that will fit into this. Now n minus 2 to Kuttima, if you take, it will fit into that. The n minus 1 to 1, it will fit into. Its volume will be 6 times Sn minus 2, and so on till S1 you will go, right? So what you have finally? This complete cuboid will be filled. Ultimately, after you have fit in all of these, this cuboid will be completely filled.
Right.
Uh, and what will its volume be? 6 times 6Sn plus, no, it will be 6Sn plus 6Sn minus 1 plus 6Sn minus 2, so on till 6S1, right? That 6 you take
Yes.
it outside, you take the 6 outside, you will have 6 times this sum. 6 times S1 plus S2 till Sn you will have. And that 6 times this summation will be the volume of this cuboid. Is that clear, or
Yes.
Yes.
now
Yeah.
what is the volume of this cuboid? The entire cuboid after it is filled, what will its volume be?
Then I guess it should be n
It
times n plus one times n plus two.
It is
by
n times n plus 1 plus n plus 2. That is all. So this n times n plus 1 times n plus 2 will be 6 times this summation. So this summation is n into n plus 1 into n plus 2 divided by 6. He gives this visual proof. You don't need to go into any of this summation of squares. In none of the algebraic business you need to go into. Just with some visualization and geometry, you can derive this particular result. Again, similarly, he describes some Kuttima procedure to get summation of squares. Again, summation of squares, in fact, today the way it is taught in most math classes is with algebra only. I have never seen this particular proof before. Again, with a very similar procedure, he constructs a different type of Kuttima. And if you stack this, go on stacking this, you will get this, the volume of this cuboid will be again n into n plus 1 into 2 n plus 1. You will again have, each of this will be 6 times. Very similar procedure, you can get the summation of squares. So yeah, these are about the visual proofs. Again, Neelakantha also comments on water clocks. Maybe this is, I mean, so water clocks. These were some instruments used to keep track of time. Now we have clocks based on quartz. The oscillation of the quartz crystal is giving us the measure of a second. For them, they used to fill a vessel with water. They used to keep a hole at the bottom, and by the time it takes to empty, they will measure how much time has passed. But if you have a cylindrical vessel, there is a problem with that. Can anyone imagine? If you have a cylindrical vessel, you make a hole at the bottom, water will start flowing out. What will it? If I if the entire vessel empties in some 60 minutes, say 60 minutes, then when half the vessel has emptied, can I say that 30 minutes have passed?
No,
Why not?
because it's not symmetrical.
Cylindrical vessel. I'm taking not this sort of vessel. If I take a very cylindrical vessel, a perfectly cylindrical vessel, if I take,
Okay.
can I say that after 30 minutes, half the vessel would have emptied?
I think pressure changes, right?
Correct, exactly. This pressure changes. So that will not be the case. So in fact, if you before this, generally when astronomers have told how to make a water clock, they have just said keep a cylinder and make. Here Neelakantha actually says nalakasya. Nalaka is the term they use for cylinder, some container. Neelakantha says nalakasya urdhvadha parinaha bhedah kartavya. You should make the cylinder radius or cylinder's diameter different at the top and bottom. Urdhvadha parinaha bhedah. Parinaha is this diameter. So you should make it not a cylinder. You should make it some other shape. He says. He gives the same explanation which you give. साम्ये तु जलाधिक्ये तत् गौरवात्. Because of the weight of water, if you have an even cylinder, samye, if you have an even cylinder, because of the excessive weight of the water, it will flow very fast. Ati vegena jalasravanat. Tad anurupam alabuvegasyapi adhikyat. They'll have some sort of thing floating on the water and pulling some other mechanism to indicate time. So because of the excessive weight of water, he doesn't say pressure, he says weight of the water, it will flow down very fast when the thing is full. Madhyahnat prageva goda chaturbhaga brahmanam syat. Before it is midday itself, 1/4 of the vessel will be empty. So he says it should not be an exact cylinder. I mean, such empirical observations seems to have made and come up with some very clear statements like this. And one more interesting aspect is that even today, many Panchanga Kartas, they say that they have some procedures for doing planetary computations based on some people use Surya Siddhanta, some people use Aryabhatiya. So their idea is that since Sun God himself or Brahma himself has come and given these values to Aryabhata, these values have to be correct. It is not possible that they can change. Uh, in fact, Nilakantha says, "Tapobhir prasanno Brahma Aryabhataya Bhaganaparidhyadikam Graha Ganana Sadhana Bhutam Sankhya Vishesham Upadidesha." Brahma, being pleased with Aryabhata's penance, himself came and gave these Bhagana, some revolution numbers, some astronomical constants to Aryabhata. Sankhya Vishesham Upadidesha, some numbers he gave to Aryabhata. Tad Upadishtam Punararyabhataha Sarvam Yathopadishtameva. As he was given, so did Aryabhata just write down. Dashabhir Giti Bhagiti Bhi Nibabandha. As he was given by Brahma, Aryabhata just wrote down just like that in 10 Gitikas. Iti kechin manyante. Some people think so. Some people think that Brahma himself gave these values to Aryabhata. Why they think so is because, I mean, Aryabhata himself says this science has been, I mean, given to him by Brahma, something to that effect is there. Tasya kutah parikshanam. I mean, how can we revise these values if Brahma himself has given it? Brahmanah sarvajñatvat ragadveshadi abhavacha. Brahma is free of any defects. Brahma knows everything. So, if Brahma himself has given these values to Aryabhata and Aryabhata himself says so, then how do you justify revising these values? That is what some people say. Iti kechin manyante is what he is saying. Nilakantha says. So they say iti kechin manyante. तस्य कुतः परीक्षणं ब्रह्मणः सर्वज्ञत्वात् रागद्वेषादि अभावाच्च अवितत्वानिश्चयात् इति चेत्. Then this is Nilakantha's reply to this sort of idea. Manda, you slow-brained person, Maivam, this is not so. Devata prasado mati vaimalya hetureva. The joy of the gods, that is, the gods having God's grace, is simply means for getting a clean brain. That is the literal translation. He is basically saying, Tapohi prasanno brahma, you do sort of a lot of penance, you get God's grace, that will make your mind a recipient to calculating the correct values. Nacha punar brahma adityo va swayamevagitya upadishet. Brahma or Aditya do not themselves physically come and give you the values. They make your mind recipient to computing new values. Evameva vakshyati chanantara sudre. He gives some examples for all this. तस्मात् ब्रह्मणा उपदिष्टम् इत्येतद् आर्यभटीयवाक्ये नैव विरुद्धम्. So he sort of reconciles. Aryabhata says that it was given by Brahma. What was given by Brahma? A good brain was given by Brahma, using which Aryabhata only computed these values. So if you see some not mistakes, if you see some differences in these values today, because the positions, rates of motion of the sun, etc., which they were there in 500 AD, need not be the same that they are today. In fact, in Nilakantha's time itself, he had some discrepancies, and that is why this entire conversation even came up. Some people were saying the old values given by Aryabhata were correct, but I mean they were not. They were no longer matching with the observations. So Nilakantha gives some sort of a clear explanation on what it means when Aryabhata said it is given by Brahma, why it is correct to revise those values to match the observed parameters, etc. He has neither rejected this divine revelation of astronomy to Aryabhata, or has he said that since it is divinely revealed, it need not be revised. He has neatly justified both sides, and that is the sort of thing he has attempted. And this is perhaps one of the crowning achievements of Nilakantha. He has actually given a partially heliocentric model of the solar system. Before this, of course, the way in which Indians calculated the positions of the planets, they involved generally two corrections. The first correction will be the eccentricity correction, like the sun, Earth is rotating around the sun, or if you should speak in their parlance, the sun is rotating around the Earth in an ellipse. It is not in a perfect circle. In some sort of warped circle, it is rotating. To account for this effect, they have a correction known as the Manda Samskara or eccentricity correction. This correction will take care of the non-uniform circleness of the orbit. They apply a second correction for the planets. For Sun and Moon, this Manda Samskara is enough because yes, they do orbit around the Earth itself. The other planets, however, they like apply some other correction because they do not orbit around the Earth directly. They orbit around the Sun that we know today. But the way that they had dealt with it was with some complicated Shighra Samskara, they will say. And some complicated procedure was there. They'll basically calculate the procedure with respect to the Sun first and then convert it to Earth coordinates. Neelakantha comes up with a unified cosmological model where Sun and Moon rotate around the Earth. All the other planets rotate around the Sun. And yeah, so for the other planets, you first do this Manda Samskara and get their true position with respect to the Sun. Then you do a coordinate transform and get their positions with respect to the Earth. So this partially heliocentric model was first explicitly conceived and stated by Neelakantha. I mean, this is perhaps what he is most famous for. And such a model was independently rediscovered in Europe by Tycho Brahe a couple centuries afterwards. I mean, not even a couple, maybe 150, 200 years after Neelakantha, it appeared in Europe. So yes, that is all I have to say about Neelakantha. That is all. I mean, yeah, we're done. Thank you. Any questions?
I had one question.
Sure.
So you told that in the Divine Revelations slide that it was Brahma. So do
Yes.
you mean Brahma Deva or Brahman, like the supreme consciousness?
Must be Chaturmukha Brahma only, I think. Even I'm not sure.
Okay.
Aryabhata
Because
says,
in the Yoga Sutras, in the
hmm.
Vibhuti Pada, we have like when you enter the Samadhi, like the Asamprajnata Samadhi, you get the divine revelations. You hear the voices, divine voices when the mind has quieted. So when a yogi does samyama, like dharana, dhyana, and samadhi, all three together on an object, so he gains the knowledge of that object completely. So in the Vibhuti Pada, it is told that if you do samyama on the sun, then you get the knowledge of the universe. And if you do samyama on the stars, then you'll get the constellation formation of the stars. So I'm just curious.
uh, I don't think that is what they're referring here because Neelakantha in several of his works, he states that the parikshana or observation to get the knowledge of the planets has to be done with yantras.
Okay.
So that is how he, even in his Grahachara, what was the book? Graha Pariksha Krama, he tells how yantras or astronomical instruments are to be used to make observations. There are multiple astronomical instruments. They, keep a gnomon, take the shadow, do some sign pass with that, and some computations are there. So these astronomical parameters, knowledge about the astronomical bodies, are to be obtained using yantras. The astronomers are unanimous and clear on that.
Okay, got it.
So
I
that's
guess
it.
these things which he said is available for concentration, and rest the calculation was done by the person itself.
Yes, correct, exactly.
Yes, that is
Mativai
possible.
Devata Prasado Mativaimalya Heturvai. So this yes, you do a lot of tapas, you will get clean mind. You will get a Vimala Mati. Yes.
The clean mind refers to the when the mind has quietened without any
Ah,
fluctuations.
yes.
Yes.
So yes, that is all. Thank you.
Excuse me,
I
can I
have a
ask a
small
question?
inquiry. Like recently, have come across metrical reconstruction. Means from I don't remember the author. Someone made a metrical reconstruction of Rigveda. So what do you think about those? Like they were like it pretty much indirectly says that there are some metrical inconsistencies that were passed down over years.
Uh, See, so the Veda, as we know it, it has been preserved in a rather strict form that has been, I mean, accepted by Western Indologists as well as Indian Indologists. There is not much debate there. I mean, even to the level of Swaras, it has been preserved in a very consistent, faithful manner. However, yes, there do appear to be some inconsistencies here and there, but I think those would be explained by the variations in this Chanda Shastra. For example, this Devi Gayatri Chandaha, or this Nitrat Gayatri itself, it is, I mean, it has one less syllable, right? So maybe things like that can be used to explain the supposed inconsistencies that we find. Yeah, and one more thing is this Vedika, this the way that syllables are to be split in Vaidika verses is also a little bit different. If you have a yan sandhi, sometimes it is not to be split like you have something chia, you should read it as chi ya for the sake of chandas. Some things like that are there. Even I have no idea. I mean, the way the Vaidika chandas portion is extremely complicated. I was not able to understand. But I think it would be explained there. I'm not. Many. I mean, yes, it is true that if you just apply the rules directly, you will not get all the. I mean, what you expect in the Veda. If it says Gayatri, you may sometimes find 7 syllables or 9 syllables, but maybe it can be explained with some of the rules in this Chanda Shastra. Is what I think. I'm not sure.
Okay, thank you.
Hello,
Uh,
Bhaiya.
before
Yes, sure.
before we move on to the next questions, I'll say the vote of thanks. Thank you, Aniket Ganesh, for taking these beautiful sessions and for patiently explaining it to us. Although I think that most of us found it a bit too technical, but then technical is always good. So thanks. That is all. I think the recording can be stopped.
Hello.
Yes, yes, yes.
Yeah, I just